multi-seminar series. We're delighted to have our state systems guy. So he comes from a background of some sensor network architect and key architect and many numbers that are related to some work on assessing quality of data and computer sciencey kinds of things, and then recently been doing more management, large-scale project management. He is the science director at ADN Technology, engineer with the GENI project office. So most recently ran into him in some happenstance way in Melbourne, Australia, of all things. I was there for a conference, and he was there for a run, basically, running in different directions. So that the subsequent conversation followed, and an invitation to come to Bloomington, which he took me up on. So I'm delighted to have you visit today. Good, excellent, good. And Vic's
when I get the stuff, it's to audiences. A lot of people here have been spending a lot of time working. Probably here to know more about some of my slides than I do. So, good. Also, these a lot more slides than I have time, so I'm going to adapt. So outside of the talk, we'll talk about what GENI is, use a simple example to introduce how GENI might be used. Talk about GENI's growing suite of infrastructure, how it's growing, what experiments that are currently being run on GENI, or sampling and plans for GENI and large effort that's taking off right now, and then finally an experiment that's so we all are familiar with global networks such as the internet, we use them every day. All these networks, but we don't often understand how these networks work. Issues we find out where the trouble spots are and fix them. But we really don't understand the science behind these networks, and so there is this need to understand the behavior of these large complex networks. There are innovation issues related to the networks. So, internet is a production network. Applications such as banking, Facebook updates. You can't go mess with the network. You can't, if you have an idea for code routing protocol, you just can't go and convince AT&T or whoever to go with this piece of software. So all the innovation that's happening in the internet today happens at the edges. New kinds of services that are being deployed, new kinds of client-side applications. But data innovation is the core of the network, because you can't go mess with it. And that's a substantial barrier for innovation for these networks. Finally, we rely on as a society, we rely on the internet, yet we cannot, we know all these privacy and security issues. Can really trust the network. And so to attempt to address all these issues, the NSF is funding a test bed to address these issues, to test try out new kinds of protocols, try to understand the science of networking, recognizing experiments. So it's a laboratory. GENI is a laboratory for exploring future internet at scale. At scale, people often ask, well, what do you mean by that scale? And it's really And so GENI opens up research for opportunities for looking at research we hope for rapid innovation. There are two key concepts that underlie GENI. One is the notion of slices. And really, GENI is a shared test bed. It can have multiple people running multiple experiments. The notion of a slice is what allows you to share this test bed. So an experiment lives within a slice. A slice is a collection of resources. That's one concept. The other is deep programmability, and program any part of the network. You can program endpoints, you can program firewalls, you can program switches. You can put your software anywhere in the network, not just in that's what allows you to innovate at different. Here's a graphic that explains some of that. So here we have two experimenters using sources. They both like share routers or network sliced. So each gets his software in different parts of the network. This one router here could be software and the software. This test that is today being used by multiple future internet architects. There are four large future internet projects that have been funded by the GENI is growing. This is a map showing courses in GENI institutions. The backbone networks are Internet 2 and National Random Rail, both of which have donated patents. Layer 2 layer 2 networks across resources. And put your own. As an example of how one might use GENI, so this is kind of a cheat. Here we have an experimenter. Why he has test tubes, I don't know, but he has this notion of a new idea for a protocol stack. So he said the original internet was designed to connect. He has the notion that the internet really ought to be, or the future network ought to be. And so the protocol. He has an idea, he writes it up, and then the usual comments you get from the reviewers about, well, good idea, but scale, or what about security, and so on and so forth. So he goes and, like any good experimenter, implements his new protocol stack, tries it out in his lab, things work fine. Now he decides he wants to test this at scale. Some resources in the backbone, get finite space stations perhaps, which are part of GENI. So computing resources to the back. So he creates a slice and adds to the slice resources. Routers, he puts the software into finite space. And he has a new service up and running. And now he can invite people to use the service. It's part of they can access the service from here. And perhaps they like the service and they tell their friends about it. Real users using the service add more resources to the slide. So has what we call GENI parlance. Users who opted in to use a parameter to get real world data. So people might access the service in different ways. Maybe through an app and that might come through the internet or through special applications on your machines that might access the same laptop here might access different services. So anyway, so this experiment is a great success. You know, he does a lot. Publisher that is happy. Obviously, not every GENI experiment is going to have. The hope is that it's at least useful for public real users. So if you have an idea for a new protocol stack, something basic global funding is the state fund that work. Once your idea is mature, once you think you've got built in your lab and you'd like to actually try it out at scale, that's when you go to GENI. So in terms of funding, the different size use GENI. That's your. So GENI is meant to enable at-scale experiments that may or may not be compatible with the experiments. You can control the environment. Experiment where you set up your experiment, let people use it, use the service, and see what happens. I mentioned opt-in users for long-running experiments. This is probably an exaggeration right now. It's a measurement tool that we're working towards. Is continuing to grow in scale. So how does GENI grow? First, how is GENI built? We built GENI, the classical spiral development process. Each spiral is year long. At the start of each spiral, we have some objectives for the spiral. Projects, there are many projects that working project goals for that spiral are based on. We're entering GENI spiral 4, and priorities for spiral 4 are experiment support, getting more experimenters and more support for experimenters. The way we grow is, the way GENI grows, by a lot of it is by taking existing research test beds. Orbit, there's a variety of different test beds that are funded by. So we separate them into GENI. So what that means is, all these different test bed implementers tool to access different kinds of resources for different. Also, a large part of GENI is existing by campus networks into a production part, the experimenter part, experiment part, running experiments on the lab with the production network. A little more about it. It's using technology called OpenFlow. Especially in commercial switches and routers, take a part of the router switch and assign it to then program that the behavior of the router. So GENI grows by incorporating existing test beds. That's the reason. That's how you can build a at-scale test bed. Test bed replicate the internet. One of the successful ways of building this and is campuses already have networks deployed. We have commercial have implemented OpenFlow technology, which is what allows production and experimental to coexist. So campuses are GENI enabled, which means students can access GENI resources, not just at level 3, not just with IT. Additionally, campuses, it allows us to leverage existing. So this is where we are in campus build out. On the left, you see where it says OpenFlow. Those are campuses that have production and experimental. The top right, you have it says WiMAX. There are campuses that are base stations. We have software that goes in the base station that allows, again, different experimenters to share the same often or subscribe to these services using their handheld device. We are in the backbone resources in the internet too, and routers that you can use again. At the bottom are commercial. I mentioned National Underrail Internet 2 for the native bandwidth. And as of August 2011, we have layer 2, so you have slices that span to National Underrail. I'll show you a picture of these. Essentially, this means what this is it's a layer 2 network or a VLAN up, and they're available for you. To this layer 2 backbone using the regional network. I'll show you a picture. So this is what it looks like. The red is the Internet 2, the blue links are National Lambda Rail. And so if you are at a campus such as Indiana, that you're of course very well connected. And connect to use that VLAN, and let's say you want to talk to the first path, that's where there's an how you can set up a layer 2 network. So this backbone is in place. It's permanently set up with running that experimenters can connect. A lot of the growth plans in GENI for Spiral 4 include doing this backbone network. There are a large number of groups engaged with GENI, as I mentioned, Indiana University. We have that philosophy based. So experiments are people are trying to use GENI for experiments. At the lab, a year ago, at GEC, all experiments by graduate students, and I guess they showed how they could use GENI to. This was the first time they had a chance to actually deploy it. A lot of work at that time, a lot of hand doing very tools and took a lot of telephones and Java channels. Things have gotten a lot better. Still not easy to use, but it's not. Just to give you a feel for the kind of experiments that ran, there was a experiment that was based on IP and that allow users to select their own network. It was an experiment. It was possible. It had. There was another experiment which was a content distribution network. The reason they could do this was because they were able to put their own sort of typically what happens in the internet today is lots of content and then send the content to the cache information. Increase the amount of retransmission. Whether nowcasting was involved UMass. So one of the resources in GENI is a radars. These are based in UMass. They have a, you can actually, as a GENI experiment, get a slice on the weather. Say, I want to steer this weather radar point in this direction and Think of it as a sensor, it's a high bandwidth sensor. So they had this notion of forecasting, which is so. I want to know, or if there's a weather event happening, say, hour from now. So what they did, what they do was get weather out of the resources they use Amazon. So it's highly personalized weather prediction for the very near-term forecast. And used high-speed GENI back the network. It was connected to Chicago Star. Where they process that to finally, Asterix was a in-network load balancing application. From typically, if you do load balancing the network today, you at egress points, you try to randomly what they did was in the network made decisions as to which change this aside in the network depending on these are the kinds of experiments people have done. All of them they were able to do this because either they were able to software applications. What's next for GENI? Looking forward, we're looking to grow 100 to 200 campuses. GENI enable the campuses, which is putting open flow technology in these campuses. The advantage for a campus when it becomes GENI enabled is that students are app or access to novel services, not the otherwise provided. And you know, it's quite possible that that eventually services become become popular, and that becomes the way that people, for example, do email. They spam through email services because they're not using IPs and they have more control over who's sending messages and people might start pointing their email clients to that service. And getting the campuses is important because that's where we have partners who will try to technology. So this is kind of the architecture starting with the right, that have open flow or GENI enabled. And have what's called a GENI rack. So it's just a regular rack. It's got a bunch of compute resources and what that does is provide compute resources, storage. Multiple campuses, but also distributes resources around the country, so experimenters can get resources from that. And then you need the regionals, of course, if you want to do open, if you want to do that. And then finally the ISPs and others that connect. The thought is one will still use the set up a layer to networks as a control plane, the control software that sets up the layer to network that software in your resources you use the internet. Once the data plane is set up, that's where all the experiments and so we've been working towards deploying GENI in campuses. What's really exciting is in this pilot, the number of regional networks that have come for wanting to enable in the next pilot closer to where was US Ignite effort, which is cities interested in a few here know more about this than I do, but this is a essentially setting up open flow switches, point open flow switches and all the internet points, allowing people to set up flows there. And the experimenters can get access to this. I mentioned GE racks, and so this is think of this as lots of clouds distributed across the country, mini clouds. Compute resources from different parts of the country. Formats. So in solicitation tree is more of a programmatic thing. Formats, base stations going in. I mentioned US Ignite, which is an exciting development. So this is a initiative out of the White House to provide high-speed, provide high bandwidth to cities. To be part of this process, and the focus is areas of national priority. So these high-speed networks are meant for to fix that and it's meant to be sliceable as we can have multiple. So it's the NSF and resources with GENI. That means is now not only will these high-speed networks be used for citizens, but also means that GENI experimenters provide their own services, experimental services. I'm not going to go with the architecture, but there are 6 cities that are very interested. The last GEC, there were people from the city, groups of people who were posters where they would get feedback what they would like change. And there will be a after these federal government, there will be a call for proposal for novel applications for a lot of the people who had ideas. And obviously, I was excited for you can get access to citizens. You have an idea again for a service that you would like to apply, which service that you might want to use either over IP or that's exciting for GENI experimenters. So the whole US, I think, is private-public partnerships. So private companies can deploy applications on and then with GENI, you have not just networks, but you have access to deploy new service. You can start with inexpensively. This is how we expect GENI together so that the existing ISPs, what that's some GENI equipment to these GENI equipment would be rack plus switches, open flow enabled switches to I'm going to spend the next 10 minutes or so talking about what does GENI look like to an experiment? How do you use GENI? Think about experimentation with GENI, experimentation in general. This is kind of like what you apply. What are the tools and resources I have? Once you decided what resources you want to use, you need to develop software for those resources. So you can program that, then you go deploy your experiment, and then finally execute it. So I'm going to talk a little more about what happens in each of these boxes, what tools you might have. And there is a growing set of tools to support different parts of this workflow. So starting with experiment planning, so first you want to know what resources do I have access to, what resources does GENI have. The place to start is there's something called So the kinds of backbone networks have access to. You can click on any of those. Of course, we already click on there to get more information about the resource. So you have the backbone networks, and you have resources such as programmable hosts, the Planet Lab that many of you might be familiar with. Programmable networks, for the backbone nodes, for example, to tell you about who owns this resource, how it points you to documentation, so what your support. So this is a good place to start to find out what resources are, and tell you what these resources are, how you can point your documentation on these resources. Once you find your resource, and these help pages also tell you what tools you can use to program these resources. Right, that GE does have the resources you need, and you have access to them. Multiple ways of doing that. If you're at the GE engineering conference, you have a help desk there. You can ask to go there for an account. For students, we require that they're advisors. So it's the need one responsible person who can and then once you know that you have the resources, you have an account, now you develop software for these resources. Obviously, the tools you use to develop software for these resources depends on the resource. You want the resources from your. Then each aggregate, each resource provider has. Develop your software, you want to deploy the experiment. And as I mentioned earlier, all GENI experiments live within a slice. A slice is kind of so experiments live within a slice. Is responsible for this slice. So the accidental or so how do you create a slice? You go to something called a slice authority. Slice authority is 8 slices on your behalf in the system. Currently 3 slice authorities in GENI, one run. Go to any of these with your account and ask them to slice, and back a slice credential. Yes, who has the slice credentials has not been able to operations on the slice, such as so then there's so you have a slice, and now you add resources to the slice. In GENI, resources that are assigned to you are called slice. Is a resource that you get from a. If you go to Planet Lab, for example, it's a virtual machine. So those from Planet Lab can have multiple versions. Go to Emulab for GENI, you can get entire PCs. So a PC that you get backbone network, it could be like Emulab. So these are servers. And the way you ask for resources to negotiate is through some aspects of resource specification. So it's kind of like a machine language. So it's a here's an example of an aspect. It's a request for a single node. So as you can see, fortunately, there are tools that hide top aspects from you. So how do aspects work? So there are three kinds of aspects. There are things called advertisement aspects, request aspects. So an aggregate, if you go to an aggregate and ask it, tell me the resources you have, list your resources. I have 50 PCs, or I have virtual machines, or I have netted PCA, whatever. Then you can, what you do is create slivers. So you're asking an aggregate or a resource provider. An aggregate is essentially a collection for slivers or resources that you want from. You specify in your request aspect what you want. You say, I want 5 virtual machines. I want 2 links. I want these virtual machines connected by links. So that's all in your request aspect. Just say, these are the requests. What you get back is a manifest aspect. So this is the manifest will have things like 5 virtual machines. So here are the 5 IP addresses for the 5 virtual machines, operating systems running on these virtual machines. And in your aspect, you might have said, I want 5 virtual machines. All the information essentially you need to be able to access cases of links, it will tell you these are the MAC addresses. Varies from aggregate to aggregate. They often have a time associated with them. Go back and view this slide. It varies. Emulab is days, but there's some that are hours. And that's actually a problem you realize when you get we're looking at enhancing our tools.
Use model that someone would go through.
The use model is when you're ready to run the experiment, you go get the resources. There are control frameworks like Orca, for example, which has this notion of not yet